right, now let's go over some forensics topics, particularly around file headers, magic bytes, and the Binwalk tool. All right, so first we're going to understand file signatures, headers, and magic bytes. Then we'll do an intro to Binwalk, go through some demos, see what that's about. Throw another tool or two in there along the way, and then some advanced forensic techniques, we'll call it. Don't quote me on that. It'll just be like some different ways of using Binwalk, other than the obvious straightforward one. Okay. Why do file forensics matter? So if you've ever investigated malware, worked on incident response, or just dug through a file system looking for something suspicious, things are not always what they seem. Attackers are constantly finding new ways to hide, embed, or disguise data inside of legit files. We could potentially want to uncover malware, hidden payloads, or data exploit attempts from not so obvious objects, I guess. And then during investigations, we could be performing file forensics, malware analysis, could be breach investigations or data recovery. All right, that's why we would do it. So how would we do it? So each file is composed of bytes. The first few bytes define the file format, and each file type has a unique signature. So I've got some of them listed here, and we'll go through others as we go along. You can use these to detect spoofing or identify hidden payloads with file recovery, or aid in file recovery, and like figuring out where the file begins and what type of file to carve out. Again, we'll go through this here in the demos. But importantly, the file extension doesn't matter at all, really, when it comes to forensics. That's for you and I to understand what it's supposed to be. The magic bytes tells the computer what the file actually is. In addition to that, or an expansion of the magic bytes, is file headers. So file headers is more detailed information about the file. So some metadata structure about the specific file, the size, the encoding, the format version, etc. This is a variable length depending on the type of file. And so while they're similar in that they're at the beginning of the file, it's those first couple magic bytes that determine type verification, type validation. So if I rename a text file to JPEG, that hides it from most prying eyes, but you as the witty and aware forensic investigator, to look for those magic bytes, and especially when you see a diff between what the magic bytes are telling you the file should be and the file extension, it leads you to investigate further. There's something there that you need to dig into. All right, and then the file headers are used for deeper analysis or extracting or reconstructing the actual files. All right, so let's take a look. So here is an example JPEG. Let me get over to my Kali box here. And it's been acting up here, but let's see what we can do. All right, so we're going to do what I have here. Let's see where I'm at. Oh, this thing's been acting up with my monitor here. Okay, so I've got this file here that this image. I guess I could browse to it here. You can see Binwalk 003, whatever, right? JPEG. It's a JPEG. It's really a JPEG. Okay, so we can do things like we can look at the bytes for this JPEG. And what we're looking for is the FFD8FF, those first magic bytes. So it's a JPEG. Pretty cool. We can go further down and see, particular file formats, whatever. All right, the rest more into the header, right? This aligns with what we believe it to be because the extension says JPEG. If we just check the file type, it is, again, confirming our suspicions. It's a JPEG. That's all there is to it, right? No big deal. Okay, so if I change, so let's copy that over to not a JPEG. Text, okay, that I can no longer view this as a JPEG, right? It tries to open up a text document. That's crazy. That doesn't make any sense. I mean, it's a little bit clear here. I see JFIF, and so I can work with that. But if I was just, again, a casual observer, looks like a text file, not what I'm looking for, move along. However, if we check those magic bytes again, it retains that JPEG header. The magic bytes remain the same, no matter what we call the file, no matter what extension we give it. Okay, so that's just reiterating that the computer doesn't really care what the extension is. That's a you thing. Okay, so how does this help us? So I'm going to switch gears a little bit. I'm going to introduce Foremost because it's pretty cool too, and it uses some of the same. It uses file headers to scan through an image and recover or extract files. So these could be images from a memory dump, extract objects or documents, files, whatever, from a forensic disk image, recover lost files after a ransomware attack, like they were deleted, or reconstruct evidence from unallocated space. Depending, I guess, on what kind of forensics you're into, what type of investigation you're doing. All right, so I think I've got a demo. No. Well, I was going to do a demo here. Let me just wing it. Let's see. I have image.dd here. So this is a disk image, right? So I am trying to recover deleted files from this image. So I built this image with deleted files in it, and I'm trying to recover those files. So if I could try this, and the file types so here's what I'm doing. I'm running Foremost. I'm looking for particular file types, in this case, images, from my input image. I want quiet verbose, and then I want to output to /output. I'm going to make a directory and put everything, all the extracted files that I can find in there. And by I mean Foremost. We'll let the computers do the work here. All right, so that disk image, and I guess I should have maybe mounted that and shown you that some of the things were missing, but trust me. But from that, 37 files were extracted, and we can view those here now in our output, and it separates things or organizes it for us by file type that we requested. So again, here's my JPEGs, all recovered. I've got some at least one PNG in there. All right, so neat tool. Again, it's using file headers to extract and reconstruct files, whether or not they have been deleted or not, as far as the humans are concerned. Okay. I gotta remember to go back and put a slide in here for that. Okay, now we're going to get on to Binwalk. It's going pretty quick. So Binwalk originally built by Refirm Labs, our friends who we love and have since been acquired by Microsoft. So they got bought by Microsoft and integrated into their company and their technology, integrated into Microsoft Defender for IoT. Pretty neat. It's a little bit reassuring knowing that those guys are working for Microsoft now. So Binwalk was originally for firmware analysis for hardware hacking or like routers and stuff like this. And is a binary analysis tool that scans for known file signatures and embedded data. So it auto detects things based on its signature file, and we could talk about that here in a sec. And it's looking for hidden files. So it was again originally built for firmware analysis, but is just as useful for malware investigations, forensic analysis, or vulnerability research. The key thing to remember here is that Binwalk doesn't just tell you what a file is, it helps you break it open. So, for example, if you're analyzing a firmware image, it might find a zip archive hidden inside, a script or a configuration file embedded within, or an executable payload inside a supposedly safe firmware image. So it's a pretty powerful tool for malware analysis, supply chain security, and reverse engineering. Let's do it. All right, so we're going to view, I did make a slide for this one. Okay, we're going to view our original file. And our original file is what? More than meets the eye. So I've got what appears to be the same image we just looked at, right? So I've just renamed it More Than Meets the Eye. Looks like a JPEG, opens like a JPEG in my browser here. If I do the regular tests here, right? So if I'm like file More Than Meets the Eye. Okay, cool, it's a JPEG. So far, so good. More than meets the eye. All right, so my magic bytes are the same, FF8, FF, D8, FF. That matches what I would expect a JPEG to have. Okay, so we think we're done. But if we look closer at these two files, the size is different. And that size is not just me renaming. So interesting. I know because I did it, but it would be strange if I had the same image, same size, same everything else, like same dimensions, I mean, and the file size was drastically different, or even modestly different in this case. Okay, so we can use a tool like Binwalk, and so we viewed it in the browser. I'm gonna run this Binwalk command on it and see what happens, right? Okay, so this has got to be scary for people that learn it for the first time. It's a really neat way to embed files or like hide files, because who the heck is running around running Binwalk on everything? Anyway, what we got is our original JPEG, okay, and then we also have a Linux executable. So what the heck? So what it did is it puts this, makes a extracted folder for me. So similar to Foremost, that's kind of why I showed you before. It doesn't care about the file names. It's just going to extract everything it sees based on those file headers and the offsets and all that. All right. That image is still the same. I still have that JPEG. Nothing changed about that. What was also embedded in there was this executable file. So if I go into that extracted folder, right, and so don't do this. I'm going to do it because I made the script. You would further inspect that executable, right? So I guess let's do that, and we can see that it is a 64-bit Linux executable, and we wouldn't just make it executable and run it, but you know, YOLO. So if I just run this script now, so made it executable, run the script, and then all I've got here is a print this line out. So if you're doing a TTF somewhere and you're trying to find the flag, maybe that's what happens. This is not super complicated because really you could just in another case you would be grubbing for flag or whatever, and you can pull it straight from strings. It's not really hidden. It's a silly example, but you get the point. That image to 99% of the whole world, more than that, is just an image, no matter how many times they look at it. So Binwalk helps us ensure that there's nothing embedded within there, and that's why it was built for firmware images that and supply chain security initially, because like there's all kinds of crap in there. All right. So you can get pretty complicated with Binwalk. And I didn't want to go too far into it, but why not do a little bit, right? So here we are. It's a Binwalk presentation after all. So here's what I'm getting. Here's my walkthrough of here's what I did, I guess, the walkthrough of what I did, and then the output. So I first created a text file, and it doesn't, maybe that's your flag. So you've successfully extracted all layers as your flag. I put that into a text file, and then I compressed that that text file into a gzip file, and then I can use a real image. Doesn't really matter. I'm just putting image like data into images. Okay, you could use real ones, and then I could create a zip that contains those images and the compressed file. So I've got a compressed file within a zip compressed file, and then finally I can cat all that stuff into a binary file, right? So a binary object. So so this final sample.bin contains a zip file. So it contains a .zip file, which contains 2 fake images and a gzip file, which that also contains the secret.txt file. So like without this tool, like breaking this apart and finding the offsets and extracting everything and then extracting the extraction gets a little bit tedious. And we don't have to worry about any of that stuff because Refirm Labs built Binwalk to make our lives way better. So given what we see here on the screen, that's the artifacts. So when I do, I'm going to CD into here, and all I have is my final sample.bin, right? So that was the end state of what we ended up with here. So all we're building, all of this was just getting put into recursively into final sample.bin. So that's what we have. And I need to remember what I was doing. Nope. What was it? Binwalk. ME. Okay, so two things. I'm gonna wait on that. Let's just do that. Okay, so binwalk, and I'm gonna extract that. We get some output, and we can kind of see that output here. It doesn't really matter because again, it made a spot for us to go find this out. All right, so it made our extracted folder, and now we have fake image, secret. We have all of the things that we put in there, and even it gave us a second extracted folder, so an embedded extracted folder with just that initial gzip file, the secret.gzip, which was right here that we made, secret.gzip. Okay, so it just extracted everything. It put them separate and together at the same time, which for better or worse. And then our secret text is, our secret message. So pretty neat. We don't have to figure out like how many layers deep it is. Just let Binwalk do the work. And then, so one thing I wanted to show though is if I remove that, just in case. Oh yeah. Okay, so all I've got left is my binary file or my bin blob of stuff. And I do binwalk. I can so with yeah, I guess I'm skipping ahead here. Let me go to the next slide because we can do custom signatures. That's what I'm trying to say. So if you have something that Binwalk doesn't look for natively, like it doesn't have the header to look for, you can create your own magic file, is what it's called, and you can point Binwalk to that to then look for those signatures as it's carving up your target file. Okay, so let me just go back here. It's easier. Okay, so I've got my magic file set up as shown on the slide here with two custom header ABCD 1 2 3 4. Doesn't matter what. It's not going to find it, but the output. So ran on that same final sample bin. So the same thing we just extracted everything from. Because I'm telling it to use my custom magic file instead with my custom headers, I get nothing in return, which is what I would expect. I don't expect to find custom HDR or ABCD 1 2 3 4 in these actual files, right? But we could see that two signatures were checked and nothing was found. Okay. All right. So that is recursive extractions. So this is the advanced part, right? Like Binwalk is so simple. You just Binwalk, target, let it run. It pulls it all apart for you, puts it together. Usually. Sometimes maybe you have recursive stuff that needs to happen. It's just as easy. Custom signatures, a little bit different. That's where you're going to have to figure out some stuff. This is the format for that magic file. You can see I've got circled here, so it's a relatively simple file to make and test out. And then, of course, you could, yeah. There's other ways to identify custom headers, like via command line or scripting, if you were so inclined. All right, and then finally, you could do entropy analysis, so you can like better identify like high entropy areas would show where there's compressed or encrypted data. So sometimes if Binwalk won't do it for you, you might have to do, say, like you have high entropy at a particular spot, you can offset, so you can use DD to extract the image based on the offset. But we're not going to get into that, but it's a pretty picture that comes with Binwalk, and you can use it for your analysis, trying to find additional opportunities for further analysis. Okay, that's it. I thought I added a GPT image here because they're getting a little bit better. I just, over time, I want to look back and see how much better or worse they've gotten. All right, so let's wrap up. So we covered the file headers and magic bytes, the difference between the two. We used Binwalk for recursive extractions. I mentioned the entropy, but that's a little bit of a different levels than I have time for. And then custom file signatures with the magic file. So we talked about all that stuff. File forensics is not just about identifying the files, it's about digging deeper, uncovering the hidden data, and making sure like no artifact goes unnoticed. Like whether you're analyzing malware, investigating a breach, or reverse engineering firmware, I think this is one of the go-to tools. Super powerful for extracting hidden files, and then with the additional like advanced level stuff, then it gets a little bit crazy how much you could do. I think it's like overly, like way too simple to embed files within other files, make them look correct. Like back to our first example here, where was it? Here, where we had that same image and in it is an executable file. Like, yeah, I'm still, after decades of doing this, it impresses me. Like it's just really neat and scary and awesome at the same time. So don't ever take what you're looking for granted. Just because it's an image and it's showing up as an image, and everything looks right. It's worth digging a little bit deeper. So don't stop at the surface, especially if you're looking for something specific or you have like good target data. Dig as deep as you can to ensure that you can walk away knowing that you've tried everything. So, all right, there's a line there, I'm sure, but okay, I'll stop rambling. I just think it's really neat. So, okay, again, I hope you got something out of this. Go check out Binwalk. It got added to Kali some time ago, so it's on there by default. I'm 99% sure I remember that happening. If not, you know how to load packages. Yeah, that's it. Play with it. Have fun. Learn more.